Hello and welcome to Advanced Quantitative and Mixed Method Research Methodologies. Today we'll be looking at measurement and scaling in research. Specifically, we'll be focusing on validity, reliability, and advanced psychometric techniques. I'm Felix Nenenate and I'll be taking you through this presentation. With this presentation, we will be looking at the introduction to measurement, scaling techniques, foundational concepts of validity and reliability, and we'll crown it up with advanced psychometric models. What then is research, or what then is measurement in research? Fundamentally, we will say that measurement is basically the process of assigning numerals to objects or events according to specific rules. Now, these specific rules or guidelines will help us in order to assign numerals or label events or objects in order to translate abstract construct into quantifiable variables. When you have variables that are not quantifiable and they're in the form of abstract, through measurement, we'll be able to convert this abstract into quantifiable variables. Now, as art educators, one will ask, how does measurement benefit art education? For starters, we'll be able to use measurement to assess visual observation skills. Measurement can also be used to measure aesthetic sensitivity. What we mean here is that we can use measurement to measure creative thinking or assess creative thinking and visual literacy. We will be able to evaluate creative self-efficacies, capture reflective capacities, as well as document program effectiveness. One of the tools that we'll be using is scaling. So one will ask, what is a scale? In basic terms, a scale is a tool or a mechanism by which individuals are distinguished from one another. Here, the degree of sophistication in scaling moves or graduates from one level to the other. So for instance, if you are having or you are trying to gather data or variables using the nominal, which is the basic one or the basic type of nominal scale, then the data or the data that will be gathered in it is not as many or is not in greater data as that of using the ratio scale. So we have four basic types of scale. We have the nominal scale, ordinal scale, interval scale, as well as the ratio scale. What we need to know is that in measurement, we are not looking at any mathematical process as you might think, but rather we are looking at practices or set of practices that will help us in order to quantify variables that we have. What then is nominal scale? In terms of scaling, a nominal scale is basically the ability to categorize without any order. So in basic terms, when we are able to put data into categories in no particular rank or in no hierarchy, then we say we are using a nominal scale. The basic thing that we need to know is that in the nominal scale, we do not have any order, there is no rank, there is no numerical value, and there's no mathematical meaning assigned to it. So for instance, if we want to classify data into boys and girls, that data has no rank. We only need boys. So we have this number of boys, we have this number of girls. It is not in any particular rank, or it doesn't have any particular value assigned to it. Then we have the ordinal scale, which then assigns rank or an order of observation, but this time around it lacks equal interval. What we mean by this is that with the ordinal scale, we are able to involve rank, put them into first, second, third, where the first may be better than the second, or the second may be better than the third, but we cannot measure it, or we cannot put them in terms of groupings, or in terms of a gap between the first and then the second. Let me give a typical example. When we are doing a research and we are using the Lackett type items, where we may want to look at how effective a product or how effective an artwork is, and we give participants an option to choose between whether they agree, they disagree, or they strongly agree or strongly disagree. All these things are rank with which they confirm or they confirm what they agree to, but it doesn't have any intervals between them. So a Lackett style item sample that we use in research is a typical example of an ordinal scale, where there is rank, but there's no equal interval between them. What then is an interval scale? With an interval scale, basically what we look at is it possesses equal intervals but arbitrary 0 point. What we mean over here is that there is difference in the measurement between the items, but they have no true zero in terms of measuring it. So here, when we say an individual scores zero, the zero does not mean the absence of a trait. So for instance, if you are an art educator and you want to measure the you want to put value on a shading technique, let's say hatching. Once the student is able to produce an artwork, there is no way the student is going to attract zero. So here, zero is not absolute. And then when you give a student zero, it doesn't mean there's an absence of a trait. Definitely, there will be a figure, or there will be a substance to it. So interval scales are rarely used in art education, but doesn't mean they don't use them. They are rarely used. What we mean is that you can't, in terms of creativity or in terms of aesthetic quality, you cannot use an interval where you award a 0 marks, where the zero means that there is absolute, or the score that it doesn't necessarily mean that the trait is not there. Now we move on to ratio scales. Now in ratio scale, what it means is that there is a meaningful 0 point. So all the properties that we've explained, from nominal to ordinal to interval, can be found within the ratio scale. There's equal gaps between the numbers. The crucial point is that the zero is a true reflection of the 0 point that we have. So for instance, you are awarding assignment, or you've given 3 hours for students to do a work, and the student fails to show up. Now in your measurement of their effectiveness, the zero that is awarded to the student because he or she didn't show up is a typical reflection of a true zero. So that is what ratio scale is all about. So to summarize everything, we have the nominal scale, where we categorize without any specific order. Example, when artist preference, or you are using media preferences, we put them without any specific order. Or the ordinal scale, where there's rank but there's no equal interval, or the interval scale where there's equal intervals but arbitrary zero, and then we have the ratio scale where we have equal intervals and then a meaningful zero attached to the measurement. Now we look at what the concept of validity is all about. Validity, in essence, refers to the degree with which evidence and theory support interpretation of test score. With validity, there is a distinction, and the distinction is that visual observations too, or visual observation is not inherently valid. So the evidence may be there, but it doesn't make it what valid. Rather, it is interpretations that are drawn from the scores that will make the work either valid or less valid depending on the context and the purpose of the work. So we have different types of validity, where we have the construct validity, we have the criterion related validity, among others. But when we look at construct validity, we are looking at the degree to which an instrument accurately reflects a theoretical construct. What this means to suggest is that the construct validity answers deepest or the most fundamental questions in measurement. What you are measuring, construct validity will ask you, are we actually measuring the theoretical concept? What you try to measure, are you really measuring the theoretical concept? For instance, an unobservable trait like creativity or ethics or visual spatial intelligence, all these things are traits that cannot be seen directly. And therefore, when you are trying to measure this, or you are trying to use validity to measure all these things, we then use the construct validity because it is a theory that we are trying to construct. It is a theory that is, we try to, the word is we infer from them, from the behaviors that these traits are advancing. So creativity, we cannot directly see them, but we can infer. Visual aesthetics or spatial intelligence, all these things are traits that are theoretical. We cannot directly see them. So what we do is that we gather the data and then we infer from the behavior that this instrument or this data are putting or are churning out. We have convergent validity, where it correlates with measures of similar constructs. So when you have two similar constructs and they try to merge or they try to converge at or relate to each other, then we are using a construct validity, whereas discriminating validity also attains. Then we have criterion related validity, where criterion validity simply means we demonstrate relationship between two instruments or two instrument scores and an external outcome. So in basic terms, criterion validity answers the question, does your test score accurately predict or correlate with real world? That is criterion. When the two things that you are trying to measure, the instrument will relate to the external outcome. I'll give a typical example. If you test your student on color or a color theory and you set an objective question and the students are able to answer the question, we will now use criterion related validity to see whether in real world the students will be able to apply the concept of color theory that you've used in mixing colors, in selecting colors and applying colors. When these two are able to relate, then we say we have a criterion related validity. Like others, we have two types. We have the predictive validity, and then we have the concurrent validity, where the data is presented, or we correlate with present criteria. Let's look at reliability. When we talk about reliability, we are talking about the consistency or stability of a measurement result. When the data that you've collected or what you are measuring, there is consistency within it and there is stability within it. Now, it is important to know that a measure can be reliable but not valid. So, for instance, if you have the typical examples that we have is that if you have a broken clock, what it means is that this broken clock can give you a consistent time or a stable measurement at a particular time. Now, it means that within a 24 hours, you are going to get two time, the clock is going to read two times accurate, and the rest will not be accurate. So reliability, the point is that reliability does not mean that it is valid. Once there is consistency, we'll be able to work with that, but it doesn't mean that all reliability samples or results are valid. Different types of reliability. The basic ones are the test retest reliability, internal consistency reliability, and then inter-radar reliability. With the test retest, what it means is that because you want to have a reliable data, we, there must be consistency of scores over a period of time. So you administer a test, say within the beginning of the week, and then midterm you try to also administer the same test to see whether there is consistency in the score. It also means that same instrument administers twice. So you have the same set of data or the same set of test instruments. You administer it twice to find out whether the scores that is attained is reliable or there is consistency within within the data. Now, in art education, measuring stable aesthetic preference, visual thinking, and dispositions are all ways by which we can use test retest reliability to measure all these things. Internal consistency reliability, where there is homogeneity of items within a scale. So we realize that these items are able to relate to each other. There is a common factor that is established between them. A typical example is when we use the Cronbach coefficient alpha. In art education, it is very helpful when we use internal consistency reliability. Then finally, let's look at the inter-radar reliability, where there is an agreement between multiple radar or observers. So you observe two things or multiple things, and then you are able to realize that there is an agreement between the data that you've collected. That is what inter-radar reliability basically speaks about. So let's look at psychometric models. Basically, when you have a set of frameworks that you are using to measure unobservable human traits, that will give you a mathematical or statistical analysis of that human trait, then we say we are deploying a psychometric model, a framework that can be used to measure unobservable human traits. That is basically what psychometric models are all about. We have key psychometric models, and I would like us to focus on classical test, item response theory, multidimensional uh, item response theory, and then the latent growth curve models. These are four psychometric models that we would like to look at. The classical test theory basically focuses on just a single true score. So with this theory, when a student is able to attain a specific mark or a score, we read other judgments or meanings into them. So they are just one dimensional true score, and that is it with classical test. It does not give us enough information about the data that we've collected. So in basic terms, we use right. So classical test theory, basically we are using them to advance or ask simple questions like how does learning happen, or has learning taken place, or what's the best way to do a particular work. All these things are things that classical test theory is able to answer. Now let's look at item response theory. With item response theory, it means we have a precision of probabilities. So we try to model probability of a specific response based on the student latent threat. For example, when we have aesthetic sensitivity, basically we can ask the difficult questions like, is this artwork too obscure to analyze? We can use item response theory to answer some of these questions. Finally, we want to look at multidimensional item related theory. Basically, there a single response or a final grade is driven by multiple underlying threats. So we may have different uh, one response, but we try to look at it from different or multiple dimensions. In art education, this is very reliable, and this is what we can use to derive enough information or measure enough uh, data from what a student produce. So for instance, if you have a project work, the first dimension you are going to look at is the technical proficiency. So in terms of technical proficiency, we can be able to ask the question, what was the level of brushwork, or how is the brushwork being applied, or if it is, let's say, perspective, how is the work, how is perspective being depicted in the work. Then we have the second dimension, like the conceptual originality, how ideas are generated. All these things are multi-dimensional item related theories that we can apply. The originality of the work, the idea that is used to conceive, are all dimensions that we can use to derive response or measure reliable scores from the work that we produce. So contextual awareness, how is the learner able to engage with indigenous or contemporary items in order to come up with all these things. It is in the form of context. The contextual reality of what is being produced is used in this measurement. So with multidimensional, we have all these things that we list above, or we list in order to deduce meaning from a work that is produced. Thank you very much for this, and I look forward to seeing you in the next video.